right, so we're going to talk about bearings today, and two of these problems are word problems. So when you get to them, if you're taking notes, then you probably need to pause and then look at the notes, or write the problems and then look at the notes. Um, Other than that, it's only a little bit of writing. So I just wanted to talk to you guys about bearings, and I'll say kind of what I said in class that, people will say, oh, I lost my bearings, right? And when people say that, they mean they lost direction. So bearings have to do with the direction of things, and how we write about those. So a bearing is basically an acute angle formed by north-south line. So if you think about a compass, you have north, south, east, and west. The bearing is an acute angle formed with the y-axis, essentially. And what it really is showing is the direction something is pointed. And that's all a bearing really is. So it always has north or south first, and then east or west second. And in my head, the way that I say it, I know it says north 30 east, but I say in my head 30 degrees east of north. That makes more sense to me. So if I was going to draw that, I have my north, south, east, west, and I would put 30 degrees east of north. So this is the bearing. All right. So we're looking this way, east of north. See if you can draw 30 or 65 degrees east of south and then come back. All right, so 65 degrees east of south would look something like this. We're looking that way, 65 degrees. All right, so that's how you draw bearings, and you can do these by themselves, or you can add them onto the ends of other bearings and look at how they look. So let's look at how this would look with a trig problem. A jet takes off bearing 28 degrees east of north and flies for 5 miles. Then it makes a left turn and flies 12 miles. If the operator wanted to locate the plane, what bearing should they use? So first we're going to draw a diagram. And the jet is bearing 28 degrees east of north. Now this is not drawn perfectly, right? I'm just doing the best that I can. And then it's going to turn 90 degrees. So it's going to turn this way and fly. The first part of the trip was 5 miles. The next part was 12. So now the airplane is somewhere over here, and we want to figure out its bearing. So its bearing would be from here. We're looking for that. This angle, just that little piece. Well, that is west of north. So we're going to put northwest. And what we want to figure out is how many degrees that is. So we need to figure out an angle. Well, in angles, we use reverse or inverse trig, and we need to decide which angle to figure out. Well, we can actually use quite a few different ones. The way that I've done it a few times is I've bundled these two together into one angle. That's the angle of the right triangle. And then I have two sides, and they're both legs, so I can use tangent. Tangent of that angle is equal to opposite over adjacent. We need to use the inverse to find the angle. I guess I should put squiggly equals. 67.3 degrees. Now, this angle is 67.3 degrees, the whole yellow one. but we only need that little green scribbled area. That's the bearing. So we're going to take the 67.3 degrees and subtract from it 28 because we already used up 28, which leaves us with 39.3. Actually, it's 0.4. I should have done 0.4s on all these degrees. Now, looking back, it says that we need to round it to the nearest degree. So we're going to have 39 degrees west of north. And that's how you do it. And some will be more simple than that, and some will be more complicated than that. But it's all the same general idea. Now, I chose this next problem, and I wasn't even thinking that it's so similar. There are other ones where you'll have to use sine and cosine and all of those things, but I happened to, and not use the inverse. I just happened to choose some inverse problems. But you know right triangles and right triangle tricks, so you should be fine regardless of what you see pop up. A plane is 120 miles north and 85 miles east of an airport. So let's say here's our airport. We're 120 miles this way and 85 miles this way. So let's say our airplane is about right there. We make the bearing with the north-south line. So I'm going to move my 85 up there. We want to know the bearing, so we're looking for the angle that the direction our bearing makes with the north-south line. And again, we're going to use tangent. And I'm sorry, I should have thought that through a little bit better. Opposite over adjacent, and we're going to use the inverse tangent as well. Please, please, please hear me when I say that it's not always inverse tangent. It could be any of the trig functions. So 35. So the bearing would be north, 35 east. All right, if that's not enough examples, just let me know. I can give you some more. That should be enough for now. Have a good day.